Hi, welcome back to our YouTube channel. Topic that we will have a look at today is from quantitative analysis, and topic is regression with multiple explanatory variables, and topic is calculating R square. So basically, the topic is calculating correlation, but somehow it is related to calculating R square. So yeah, and let's look at the question. The question is: consider the following linear regression model, which is your dependent variable, y-intercept, slope, independent variable, and at last we have error term. And suppose your y-intercept is 0.05, your slope is 1.2, standard deviation of dependent variable is 26%, standard deviation of error terms is 0.1%. What is the correlation between x and y? These are the options, and we have to choose right option. And yeah, you will get a sense that we will make you think when we'll be solving this problem. So before we go ahead, please subscribe to our channel. It takes a lot of efforts to come up with videos like this, and please do like as well. It will get us maximum reach to the targeted audience. Let's look at the formula, and this is kind of a context that I would like to give before we solve. So for correlation, if I compare this with a linear regression, your R square is square of your correlation. This is a Greek letter rho. Rho square is equal to your R square that we usually talk in linear regression. And your R square, which we talk in linear regression, is equal to explained variation over your square, total sum of squares. That's the formula for. I'll talk about this a bit because if you don't know these, you may not understand this uh, thoroughly. So I'll just give you the context of this ESS and TSS as well. And lastly, we have standard deviation, which is a very basic formula from quants. It's a squared deviation. When I say deviation, how far you are from mean, how far your data point is from mean. Square of that, sum all the data points divided by n, that will give you the variance. And if you take the square root of this expression, that will give the standard deviation. These are these are the formulas that we will talk about, but exact uh, exact root of this solution lies in how do we calculate ESS and TSS to calculate R square. Eventually, if you have R square, you can just take a root of that. That will give you the correlation. But how you calculate ESS, that we'll see in the following slide. But let's understand what this ESS and TSS means. So TSS eventually means if you have got certain data set, which is like say data set of your dependent variable, which could be your stock returns that you are trying to understand. So in this plot, you can think of X as a index return, just for sake of understanding, and Y as a stock return that you are trying to analyze. So how far the data that you observe is away from mean, that gives you the total sum of square. So there is some average. Say you calculate 1 month of data, you calculate average, and on the next day you observe that how far that is from mean. That will give you the total sum of square, and that mathematically is equal to some error term and explain sum of square. This ESS is something that you already expect from the past data. So if you recollect, we have CAPM equation, we have slope beta over there. So somewhere beta is something which is expected. So if you look at this graph, this is y bar, and this is your observed data. So the total difference that you see, this vertical distance, is total sum of squares, and what you expect from the beta is expect sum of square in this example, and whatever is left, whatever is not explained from beta, that is residual sum of squares or error terms. So sorry, my bad, this is residual sum of squares, which is the error term, and this is ESS. So what you expect from beta is explaining sum of squares, and what you are left, which you are not able to explain from beta, that is left as a error term or residual sum of squares. So these are the components. Total variation basically can be split between two. One is explain sum of squares and another one is a error term. And your R square is basically how much of total move you are able to explain from beta, like in our example, or this slope term in general, if I talk about. So ESS over TSS will give you R square. Square root of that will get us to the correlation, which we are uh, asked to calculate in the question that we saw. So this is a very high level context. If you want to know much about TSS, RSS, and ESS, you can click at the eye icon at the top of video. It will take you to the linear regression with the multiple variables. Over there, you can check this in detail. And yes, if you feel that your explanation is getting you the value, and like, you can watch full video and see that if you are really getting a value, then you can reach out to our team and ask for the coaching, like if you are really interested. And the below are the benefits that you will get. Excellent faculties. When I say excellent, it really means the faculties come up with the industry experience, which is like more important than just being academic expert. Like, you may you may have a good expertise in academics, but if you don't have a practical knowledge, then perhaps that will not get you much value. Like, that's the excellent faculties is referring to here. And you will have a seamless LMS, like you have got all the mocks, all the recorded lectures, and all the notes available on LMS. And the batches are weekend batches. You can, if you're working professional still, uh, like, you can attend as per your availability on weekend. So that's the best advantage. And online classes, like, you don't have to commute anywhere, like physically present. Just over virtually you can attend the classes and get the best value. And as I said that with the LMS, we have question banks, mock test, and you get a progress tracker as well. And along with FRM, this is a list that we get up: FRM, CFA, MBA Finance, Python, so or Tableau, Excel, whatever. See, along with subject knowledge, which you may get from FRM, CFA, and MBA, you need to learn how to operate tools like Python, Tableau, Excel, etc. Like, there are many tools. So you should be in a position to handle data that is related to your subject. That's what, like, it's a comprehensive package. If you think that any of your requirement is listed here, please WhatsApp on this number and team would be happy to assist you. Coming back to our question, uh, for for dependent variable, we were given standard deviation of 0.26, and standard deviation of error terms was 10%, and we were asked to calculate the correlation. And these are the formula that I just explained you in the previous slide. So let's see how to we uh, calculate. So if you notice here, this is also a deviation square, and that is getting you the standard deviation. So what I'll do to calculate TSS, which is distance from data point from mean, I'll just multiply these two. I'll just square standard deviation of dependent variable, and I'll have the sum of standard deviation square, that is TSS. Basically, what I need to calculate R square, which is essentially your correlation square, it is ESS over TSS. Basically, I need ESS and TSS. So TSS, how will I calculate is just multiply n with standard deviation square. That will give you the TSS. Let's see. So TSS would be equal to standard deviation of y square times n. So standard deviation of y square, that means your 26% square, times, let's keep n as an arbitrary. It will get cancelled eventually because it will be coming in ESS also. So we'll get cancel the n. So it would be equal to, you can just calculate 0.0676 if I'm not wrong. You can just check it out. And just be careful with calculating ESS. With sigma of error terms, you will get RSS. So you need to be careful. You have to subtract uh, RSS from TSS to get ESS. So let me just write the formula again. Total sum of squares is equal to sum of square residuals plus explain sum of squares. So explain sum of square that I need really is your TSS plus residual sum of squares. TSS that we calculate was 0.0676 plus in the same way RSS would be equal to sigma of error term square, that is sigma e square into n. So this is in fact 0.06 n. Let me write n here also, here also. So it would be, let's take n common, and it would be 0.0676 plus zero point 0.1 square, which would be equal to n into 0.0676 plus zero point zero 0.01. Zero point 0.1 square is zero point zero 0.01. Let me just write it directly instead of utilizing more lines. Let me write it quickly. Just give me a moment. Let me calculate 0.0676 plus zero point zero 0.01. That gives you, so this is, I think it would be minus, because TSS is equal to RSS plus ESS. So if I keep ESS here, TSS minus RSS, so this term would be minus, minus and minus. So we'll have to subtract it. 0.0676 minus zero point zero 0.01. That gives you 0.0576. That is your ESS. Now let me label this as 2. Let me label this as 1. Now let's calculate R square, which is correlation square, which is equal to ESS over TSS, and that's equal to 0.0576 into N, and over 0.0676 into N. So let's divide this. 0.0576 divided by 0.0676. That's coming around 0.8520. But be careful, this is R square, which is correlation square, which is equal to 0.852071. And if I take square root of that, just rub it and write properly. So correlation would be square root of 0.852071, which would be equal to, let me calculate it right away, 0.852071. Square root of that, 0.852071, it's coming around 0.92307. Like there are, like, let me make it 8. There are further decimal 692. So you can just avoid that. Let's look at the question. So the right answer for this question is answer A. But you may relate that how your TSS or R square concept was related to correlation. Questions in real exam also can be tweaked. You know everything, but uh, just to just to drill that out, you need to think. That's where we differentiate our institute as compared to others. We can make you think. It's eventually, CFA and FRM are practical exams. If you are in a position to think, you will get through. If you are habitual of mugging up, then perhaps that could be a problem. So adopt the right approach, and good luck. Yeah. And yeah, that's just thing that I just mentioned. The beautiful thing about learning is that no one can take it away from you. So it remains with you forever. And yes, thanks for watching. And please don't forget to like, subscribe, and share with your peers who are preparing for FRM, CFA, or any relevant exams. If this video is relevant to them. Thank you. Stay connected.